Alright, so this is on section 6.2, which is on drawing conclusions from the results of hypothesis tests. So in the previous section, we learned how to calculate the p-value of the hypothesis test. And today we're going to learn how to use the p-value to draw a conclusion. So the rule of thumb is the p-value is 1 minus our confidence level on the fact that H0 is false. So that means the smaller the p-value is, the more confident that we are sure that H0 is false, which is what we want. But how small does p have to be? So the rule of thumb is if we fix a number alpha between 0 and 1, alpha is called the significance level. And there are two cases. If the p-value is less than or equal to alpha, and if the p-value is greater than alpha. So if the p-value is less than or equal to alpha, then we can reject H0 at this level. So reject H0 means we accept that H0 is false. So that means we accept H1, which is the opposite of H0. And in this case, we also say the test is statistically significant at this level. So that means if p is less than or equal to alpha, then we get what we want because our goal from the beginning is reject H0. But if p is greater than alpha, then we cannot reject H0 at this level. If we cannot reject H0, that means both H0 and H1 are still plausible. So this is the worst case scenario. This means we cannot draw any conclusions. Okay. So let's do a simple example. So suppose the p-value is equal to 0.03. Then if alpha is 0.05, then because p is less than 0.05, less than or equal to 0.05, so H0 is rejected at the 5% level. That means we can accept H1 at this level. But if alpha is 0.01, then p is greater than alpha, then H0 is not rejected at the 1% level. Because H0 is not rejected, so no conclusions can be made here. So whether we reject H0 or not depends on the value of alpha. In general, if not specified, the default value of alpha is 0.05. And this is similar to the fact we choose 95% confidence interval. So it's just a number we choose. Okay, so now we need to learn how to formulate our hypothesis correctly. So remember, H0, the null hypothesis, is the one we intend to reject. and H0. H1, the alternate hypothesis, is the one we want to accept. So, for example, if you own an apple orchard, and you need apples to be heavier than, let's say, 8 ounces to harvest. Because we want our apples to be heavier than 8 ounces, then that's going to be our H1, which is the population mean of our apple weights is greater than 8. So therefore, the null hypothesis H0 is the opposite of H1. So it's population mean being less than or equal to 8. So here's some note here. The equal sign is always with H0. Okay, so once we have these hypotheses, there are two cases. If our p-value is less than or equal to alpha, then we can reject H0, which means our apples are heavy enough to be harvested, which is the conclusion we want. But if p is not less than or equal to alpha, then we cannot reject H0. This means we don't have enough evidence to justify that our apples are heavy enough. So because there's no conclusion, so we cannot conclude our apples are heavy enough. So all we can do is wait and retest later. Right.